All right, so in the last video, we were kind of looking at the overview of how to solve a polynomial equation that had a degree bigger than 2, okay? And so, we already know how to solve linear equations and quadratic equations, and we looked at this example, solving a polynomial equation with a degree bigger than 2. So this one was cubic, okay? And I gave you the big overview last time, and one of the things that we found, that a skill that we found that we needed was something called synthetic division. Okay. And so the idea is that kind of think back to the quadratic case for just a minute. That would factor into x minus 5 and x plus 1. Notice that the factors of 5 are 1 and 5. The factors of 1 are just 1. And so your possible rational zeros, the possible rational zeros to this would be plus or minus 1 and plus or minus 5. Okay. And so, it turned out that when we solved this quadratic, that we'd wind up getting these two factors that we could set equal to 0. And this is old stuff here. And we'd get x equals 5 or x equals negative 1. So we'd get those two things that worked. But, part of the reason the rational root theorem is what it is because of how things work with quadratics and where, how the 5 gives you the possible factors, here at the end. Okay. So it's all connected back to what you did with quadratics. We just didn't need to use synthetic division. But do you see how the 5 right here, this 5, using the language we had before, is a root or solution to this equation that we started with? And then notice that it corresponds to x minus 5 is a factor. That relationship is really important. And notice here, when the root was negative 1, these are the roots, okay, that we had a factor of x plus 1. See how it was a negative 1, but the factor it came from was x plus 1. That's going to be kind of important to remember down the road. And then let me just remind you how we set it up. So with this one, when we were trying to solve x to the third plus 8x squared plus 11x minus 20 equals 0, we looked at the possible rational zeros, went through the rational root theorem, and it's really based on what we noticed when we were factoring quadratics, is that if there is a nice solution, it's going to come from the factors of 20 divided by the factors of 1, okay, the leading coefficient, okay? And then that wound up just being all of these on top. And you have to do plus or minus, so it can be quite a long list, okay? But the synthetic division came in here. We're going to test these to see which of these really are going to be roots to that equation. So if I want to know if 1 is a root, I'm going to put 1 in the box, and then I'm going to put the coefficients of the terms in order. If any were missing, I'd put in a placeholder. And then this was where synthetic division happened. And see, that 1 that I'm putting in the box corresponds to a factor x minus 1. And so the synthetic division is really me trying to divide x minus 1 into x to the third plus 8x squared plus 11x minus 20. And if anybody'd rather do that, you can. But that's basically what I'm doing. This is just the shortcut process for that long division, okay? And so when we do this, here's how the process works. You bring down the first number. A lot of people mess that up. Always bring down that first number. Then when you pick up what's in the box, you're going to be multiplying. So these are always a multiplying step. This is always an adding step. 1 times 1 is 1. You write it right there under the next number. Whenever you go straight down, you're adding. So that would be 9. Then you're going to multiply 1 times 9, and that's going to go right here. Then you're going to add straight down, which will give you 20. and then 1 times 20, and write it right here, and then add straight down, and you got the 0. Now, that 0 that you got right there is the remainder you would have gotten if you had done your long division. So if you'd done your long division, you would have said x goes into x to the third, x to the second times. You would have multiplied back. You would have then changed your signs, okay, so that you could add. So you're subtracting both of those. You add straight down and see that 9. So you should see similar numbers happening. Then you bring down the next number and you go again. X divided into 9x squared is 9x. Then you multiply back, get your 9x squared minus 9x. Okay, then you're going to change the signs because you're subtracting. So you want to change the sign so you can think of it as adding straight down, adding the opposite. See, right here's the 20. This is where people always messed up, right? When we did this in previous classes. And then you say x goes into 20x, goes in there 20 times, and then you multiply back, get 20x minus 20. Then you are subtracting both of those so you can change the signs and then add straight down, and you get a remainder here of 0. Okay. All right. So I just wrote, you don't do both. You do synthetic division, but I just wanted you to see where things are. So do you see how these numbers down here are your quotient? Okay, and the remainder, this is your quotient. Okay, this is where the quotient is. Okay, this is the remainder in this form. This is your divisor right here. What you were dividing by is your divisor. Okay, and then just notice how the 1 corresponded to a factor of x minus 1, and how this 1, 9, 20 really corresponded to x squared plus 9x plus 20. Okay, so basically the synthetic division is just a shortcut for doing long division that helps you break down your problem that you started with that couldn't be factored using any techniques you know. Doesn't factor by grouping or anything. And you now know it is x minus 1 times x squared plus 9x plus 20. And then from there, we went further. We're able to factor x squared plus 9x plus 20 and find all the actual roots. So synthetic division is the focus of this video. I just wanted to remind you a little bit of the process. And synthetic division will do a lot of things. And so I'm going to go ahead and work through some, and then you can just be amazed at what this synthetic division will do. So let's see if I could do maybe the first 5 questions in one snip. So here's some problems on what synthetic division can do for you, okay? All right, so the first 3 questions are just asking you to divide using synthetic division. All right, so the big thing here to watch out for is that if you've got x minus 5, you have to know that 5 goes in the box. What goes in the box is the root or the 0. So the root or the 0, okay, goes in the box. And then you put the coefficients of the polynomial that was on top, you put the coefficients of those down. And notice it went 3, 2, 1, 0. There were no missing terms, so I don't have to put any zeros in here. All right, so the process is you bring down the first number, you multiply here, always bring down the first number, multiply and write it under the next number. Okay, you're adding when you go straight down, you're multiplying when you pick up the 5. So add straight down and get a 2. Now we're going to multiply and write that right here. We're going to add straight down and get a 6, then multiply, get 30 and put it right here. And then on this one, we wound up with a remainder of 0, okay? right, so we were dividing by x minus 5. This tells us what the rest of it turns out to be. Let me erase those little multiplication signs. I don't want you to think that that's times in between those. That was just a reminder that when you're picking up the number in the box, you actually are multiplying when you do that. Okay, so your answer to this one would be 4x squared plus 2x plus 6, and there was no remainder. So that meant x minus 5 went in there evenly, so that would be the other factor. Okay. All right, now let's try that with this one. If we put a -7 in the box, okay, we're dividing that into x squared plus 13x plus 38. So we'd have a 1, a 13, and a 38 with no zeros because there's no missing terms. We'd bring down the first number, multiply and write it next to it. Bring down, add as you go straight down, and multiply and write it next to it. Let's see. Okay, meant to do that. Okay, -42, then add straight down and I get a -4. All right, now this one's a little different, so you might want to look back at what we had before. -4 is the remainder. So when we divide this x squared plus 13x plus 38 by x plus 7, okay, if we had done it the regular way, we're not going to do it both ways, but I just want you to get used to how you write it. Then this 1 and this 6 is what would have happened up here. X plus 6, we would have had some stuff going on, but our remainder would have been -4. So the way you write your answer is the quotient plus the remainder over what you're dividing by. It's like you're writing this as a mixed number. Kind of like if you divided 7 by 2 and you had a remainder, how 7 divided by 2, written either one of these ways, is 3 1/2. It's this over the remainder, this plus the remainder over the divisor. Okay, it's like you're changing from, that's how I think about it. The degree on top is bigger, and it's like I'm changing into a mixed number. All right, so now we're going to do this one. So see how it's an x plus 2? So if it's an x plus 2, what goes in the box is a -2. Because x plus 2 equal to 0 would mean x would have had to have been -2. So we put in what the root or the 0 would have been. Now this one has a missing term. See how there's an x to the third, there's an x squared, but there's no x, and then there's a 5. All right, so bring down the first number and then do -2 times 1. So bring down the first number, -2 times 1, and write it there. It gives me a -3. -2 times -3 is +6. -2 times +6 is -12, and then add straight down, and you get a remainder of -7. Okay, so this time we got 1, 2, 3 terms. That's like your A, your B, and your C of a quadratic. So we get x squared minus 3x plus 6 plus -7 over x plus 2. Okay. Now on this video, I want to do a little bit more. I want to look at how synthetic division can be used to find the value of a function. If you're trying to find the value of the function at -3, you knew to do it by plugging in a -3, and that still works. Okay, that's true. But we're just trying to show you that you can use synthetic division to do it by putting a -3. Whatever you're trying to find the value of goes in the box. Take the polynomial you have and write it down. And then do your synthetic division. So bring down the 2, multiply and write it right next to it. Gives you a -13, multiply and write it over here. Add straight down, it'd be 34. Multiply and write it over here. So what is that? That's 34 times 3. I don't want to mess that up. Let me multiply that. That's 102, and that'd be -102. And then if I took away 12, that would be -102. 90 when I'm finished. Okay, so let me double check that. So it was 2, negative 13, positive 39. So that's positive 34. It's negative 102. And so I wind up with a negative 90. And that negative 90 right there, that's actually the value of the function at negative 3. So f of negative 3 equals negative 90. This is sometimes called using the remainder theorem. The remainder you get is actually the value of the function at that number, okay? All right, so let's try 1/2. So if I put 1/2 in the box, let me see if I can do it right here. Then it would be 4, negative 7. This one's tricky. It's missing the constant term. You'd have to remember to put that placeholder. Okay, bring down the 4. Now, half of 4 would be 2. Add negative 4 and negative 2. Half of negative 2 would be negative 1. Bring that down. Negative 7, negative 1 would be negative 8. Half of negative 8 would be negative 4. So I wind up getting negative 4. And so my answer is really negative 4. F of 1/2 would equal negative 4. If you don't believe me, plug in a half and see what happens. It's just when you're good at synthetic division, you can do that much more quickly. Okay. All right, and then let's go ahead and do the remaining problems on another snip. Okay, so let me move this. This is the real reason. This is getting into the real reason we're doing synthetic division. I think I can do all of these on this next snip. Let me see if I can move that down. Yeah. All right. All right, so let me keep these two together. Now, the next question is asking, determine whether the second polynomial is a factor of the first, to know if x minus 3 is a factor. What I'm looking for is, am I going to get a remainder of 0? That's how I know. If something divides into the polynomial evenly, it's going to have a remainder of 0. Okay, so that's what I'm kind of looking for. And so we can use synthetic division to do that. Okay, so what you got to know is that you're going to put what to put in the box. If this is the factor, then what goes in the box is the 3. Okay, so 3 goes in the box, and then the exponents here are 3, 2, 1, and then the constant. So you don't have any missing terms. Okay, then you do your synthetic division. Bring down the 1. 3 times 1 is 3. Negative 5 plus negative 3 is negative 2. 3 times negative 2 is negative 6. 11 plus negative 6 is 5. 3 times 5 is 15. And I did get a remainder of 0. So since I got a remainder, this is the remainder. The remainder is 0. So the answer to this question is yes, x minus 3 is a factor. And actually, this gives me the other factor. See, I know x minus 3 worked. Then x squared minus 2x, x squared minus 2x plus 5 would be the other factor. Okay. All right, let's try this one. If x plus 2 is what we're trying to see if it's a factor, what goes in the box isn't 2, but negative 2. Then put in the 5, the 8, the negative 3, and the 2. We weren't missing any of the terms, so there were no placeholders. Bring down the 5. Negative 2 times 5 is negative 10. Gives me negative 2. Negative 2 times negative 2 is 4. Negative 3 plus 4 is 1. Negative 2 times 1 is negative 2. Oh, and again, I get a remainder of 0. So my answer would be yes. It doesn't always turn out that way. These two did. Okay. All right. And then that means, since it worked, that this polynomial can be factored into x plus 2. And then the other one, this is the a, the b, and the c. This is 5x squared minus 2x plus 1. And then maybe that'll factor, or what we're going to really do is use the quadratic formula. All right, and so these last three are kind of what we wind up doing quite a bit of. All right, so here I'm trying to find out if this number is, in this case, since I'm using an equation here, I'm trying to find out if that's a root of this polynomial equation. So the root itself goes in the box. Then you put the coefficients there. Notice it went from 4 to 2, so I have to put a 0 as a placeholder for the cube. Then 8, then -1, then 5. So bring down -1, then multiply 3 times -1 and write it next to that. Add straight down, get a -3, then multiply, gives you -9. Add straight down, you get -1. 3 times -1 is -3. Add straight down, you get -4. 3 times -4 is -12. Add straight down, you get -7. Okay, that's the remainder. Remainder is not 0. That means that 3 is not a root. Okay, so no. Okay. All right, now what about on this one? We're trying to test whether 1/2 is a 0, since they use function notation. 1/2 is a 0 of the function. So it's 2, then -21, but it's missing the squared term, so I'm going to put a placeholder of 0 in there. Then we have the x and the constant. So bring down the 2. 1/2 of 2 is 1. And add straight down. 1/2 of -20 is -10. Add straight down. Half of -10 is -5. Add straight down. And then half of -2 is -1. Add straight down. This time I do get a remainder of 0. So the answer is yes. Yes, 1/2 actually was a 0 of that function. And see how it made the remainder be 0. Okay. All right, and then here's how we're going to use that information. So here's another problem similar to what we did before. We're trying to solve this equation, and they're giving us a hint. They're telling us that 3 is a 0 of the function. So that means that if I put 3 in the box, that I will get a remainder of 0 when I do my synthetic division, and there were no missing terms. Okay. So even though I know that, I'm still going to do it because it helps me. Okay. It helps me to wind up finding the other factor. Okay. So you see, I know that this 2x to the third minus 17x squared plus 38x minus 15 can be factored now into x minus 3, and then 2x squared minus 11x plus 5. And then I could take that and try to factor further. Okay, so I can set these equal to 0. And then when I'm working on this part, if I'm not a great factorer, I might use the quadratic formula, but I usually give factoring a try. I think 5 and 1 with both negative would work. And let me see if I can't move that out of the way. And so I wind up having one solution being the 3. I'm going to have to move this where you can see it. So let me come over here. So I have x minus 3 equals 0, which means x equals 3. 2x minus 1 equaling 0. So 2x would be 1, and x would be a half. And then notice x minus 5 turns out to be x equals 5. So there's my 3 solutions that I was expecting. It was a degree 3, so I thought it should have 3 solutions, and there they are. Okay. And so synthetic division can do a lot of things. This is primarily what we're going to use it for, these last 3 questions.